folks. I just wanted to give you a quick screencast to go over these review problems. These are the notes. These are leading up to our review that we'll be then giving to you in the next class that you come to. So each of these problems is going to be very similar in the fact that you're dealing with a table, an equation, and a graph. And we're going to give you one of the three and ask you to find the two that are unknown. So for this particular example, you've got the function, forgive me, y equals 1/3 x minus 6. And we need to figure out how to fill out the table and then complete a graph. And it doesn't matter which one you do. First, I'm going to go ahead and start with the graph. I know that I've got the starting value, my y-intercept, at -6. So that's going to be paired with 0, -6 there in the table. And I also know that I've got a rate of change of 1/3, or a slope of 1/3. Now remember, this is a linear function, so it's based on repeated addition. That means that every time I go down or increase by 1, as you can see this is going up by 1, then I'm going to be adding 1/3. Now I could substitute 1 into the function and I'd end up with 1/3 times 1 minus 6. Or I can say I'm going to take -6 plus 1/3. Now remember, when you take a negative and you add 1/3, think about that number line. Here I am at -6 and I'm going to move 1/3 of a place to the right. That ends up being -5 and 2/3. Now if I add another 1/3 to that, I'd be at -5 and 1/3. And then if I add one more 1/3 to that, I end up at -5. Now the opposite is true as well though. If I go backwards in the table, every time I go back 1, which is what's happening on the left here, I have to subtract 1/3. So -6 minus 1/3. Now think of going the opposite direction on the number line. It's going to become even more negative. So I get -6 and 1/3, -6 and 2/3, and I have -7. Again, moving backwards 1/3. So I go forwards, I'm adding 1/3, and I go backwards, I'm subtracting. Why? Because this is a linear function. Now, I take a look, I'm going to start graphing. 0, -6, my starting point. 0, -6. 1, 2, 3, 4, 5, 6. There it is, 0, -6. Then I know another easy couple points would be the -3, -7, or the 3, -5. Now those would be great points to plot. I could also rely on this slope. Since I know my slope is 1/3, I could go up 1/3 and plot the next point on the graph, which is going to be right here. Up 1/3, plot another point. Up 1/3, and again, now I easily could draw this line, and forgive me for not being perfectly straight, but you get the idea. Now, is this line going up from left to right? Am I going uphill? Yes. So it is increasing, all right? Another thing is, I know that my slope is positive. That's another indicator that it's increasing. So my first problem here is linear, increasing. Filling out the table is going to be the hardest part. If you know how to add the 1/3, another option is, again, to substitute each of these values, to put -3 in here for x, to put -2 in for x. You could do that, and that would work out as well. I think that using the pattern is a little bit more efficient. Problem number 2. You can tell now you're given the graph. Now when we're given the graph, it's pretty easy then to say, yep, I know this is linear. And it's going down from left to right, so it's going to be decreasing. All right. Then they gave you these points. They gave you the point 0, 6 up here, 0, 6. So I know that my table is going to have 0, 6. They also gave you this point down here for 0. Now that's not on the table, but what it does tell you is that in the middle here, it must go through that point, which it has coordinates of 2, 3. So you know that that point is on your graph, 2, 3. Now, by looking at a graph, can we tell its slope? Of course we can. How do we go from left to right? How do we get from this point up here down to the point 2, 3? I go down 3, and I'm going to go to the right 2. That tells me I have a slope of 2/3. Now, let's go ahead and write this function. It's going to be y equals, now what was the slope? Down 3/2. I think I said 2/3, and I apologize. It should be 3/2. I misspoke. And then where does it hit the y-axis up here? The starting point is at 6. So we'd say a +6. So we have y equals -3/2 x plus 6. That's going to be our function. Now what is the rate of change that we had here? -3/2. That means that every step along the way in this table is going to be repeated subtraction of negative 3/2. All right? Remember, if it's linear, it's about repeated addition or subtraction. So now 3/2 is the same as 1.5. So essentially, if I go down 1.5 from 6, so 6 minus 1.5 is 4.5. Now, if I go down 1.5 from that, I do get to 3, so it does work out. It matches what we got from our table. If I subtract one more 1.5, or negative 3/2, I end up at 1.5. Now, what would be the opposite? If I go in the opposite direction in my table, from subtraction of 3/2 would be to add 3/2. So every step I go in the opposite direction, I should be adding that 3/2. So add 1.5 to 6, I'm at 7.5. Add 1.5 to that, I'm at 9. Add 1.5 to that, I'm at 10.5. And guess what? Now I've got my table filled in, I've got my function filled in, and I've circled linear and decreasing. Again, starting with the graph, filling in what you know, and building from there. Final problem. Now, it's easy to see by just looking at this graph that it is nonlinear. This is an exponential function, all right? And what is it doing from left to right? It's going down from left to right. So it's going to be exponential and decreasing. Now, they've given us some points here. They give us the point 0.3, so I fill that in on my table. They gave us the point 1,1. Well, that's important. Because I know that if it's exponential, it's a relationship based upon multiplication or division. Now in this case, I know to get from 3 to 1, if this over here progresses by 1, that I had to use either multiplication or division. In this case, to go from 3 down to 1, I am not multiplying by 3. 3 times 3 would be 9. I'm actually dividing by 3. Now here's what you got to keep in mind, that dividing by 3 is the same as multiplying by 1/3. Remember our rules. Remember back in the day when you're dividing fractions, you learned that dividing by a fraction is the same as multiplying by its reciprocal. Well, what's the reciprocal of 3, folks? 1/3. So I would challenge you to think of this as multiplying by 1/3. Right? Multiplying by 1/3. All right? Now, when we go backwards, what's the opposite of dividing by 3? You can think of it as multiplying by 3. Okay? When we want to go backwards, that's fine and dandy. But going forwards, instead of saying we're dividing by 3, let's say we're multiplying by 1/3. And the reason I say that, I think it's going to be a little easier for you to write in the numbers. What is 1 times 1/3? It's just 1/3. What's 1/3 times 1/3? That's 1/9. There is no decimal equivalent to 1/9 and 1/3 that you can write and fit in the box. So that's why I prefer you leave them as fractions. Now, understand, dividing by 3. This was the same as saying dividing by 3, all right? But we chose to write it as multiply by 1/3. Now, going the other way, multiplying by 3. 3 times 3 is 9. 3 times 9 is 27. And 3 times 27 is 81. So now we have our table filled in. The only thing we have left to do is to write the function. So let's write it up here. Y equals, what was our starting value? What was our y-intercept? That was 3, right? Now in the parentheses, with the power of x, we always put our multiplier. Why do we call it a multiplier? Because we want to write in that parentheses what we are multiplying as we move down the table here. As we move down the table, what were we multiplying by every time? You don't put the divide by 3 in there. You're going to put your 1/3. Right? 1/3. As I move down the table, what am I multiplying by? So that would be my function. Be very careful with this, folks. The assessment's going to be based upon, can you, given one thing, the table, the graph, or the function, can you write or fill in the other 2 parts? Best of luck, and I'll talk to you soon.